I'm Elliot Hunt with Xcel Energy. I'm the manager of the Equipment and System Analytics team. My director, Katie Honey, has presented previously, so I'm in the same organization as her. You may have seen some of her slides from previous years. I think she was here last year, and then some previous events as well. I've got a team of 10 engineers and analysts that will support our APM implementation throughout the energy supply organization. And I'll talk a little bit about how we fit in here in a minute. I'll give a little bit of an overview of where Xcel Energy has been on our APM journey, as well as do a refresher. Some of you, again, may have seen the operational risk workflow that has been built out and utilized through our energy supply organization for several years now. I'll run through some of the history there, and then talk through as we have implemented that and worked with our users and strove to improve adoption. Talk on a couple areas where we saw room for improvement, and then kind of what we've done to resolve some of those gaps, both through an initiative with asset strategies, a heavier lift, and then also a tool we're starting to use called manual risks, and talk about how we kind of close the loop a bit high level with our budget integration, and hopefully leave a little time for questions, but if not, I'll be around afterwards. A little bit about the company. Xcel Energy is a regulated utility. We serve three primary regions, a northern region up in Minnesota, Dakotas, Wisconsin, Colorado region, and then a northwest Texas, New Mexico region. That's for both electric customers and gas customers. Again, my team is supporting the energy supply organization, so power generation. We're supporting the fleet there of roughly 21,000 megawatts of capacity, and I'll kind of highlight the difference between some of the reporting the company does. Our capacity is that larger pie chart, and that information is a couple years out of date. I checked this morning on an annual report that came out today, and it does reflect about 500 megawatts less of coal generation. So as with many utilities, that's the way we're transitioning, right? We've got a legacy fleet, thermal generation, and then a net zero goal for 2050. And as we work towards that, we're making sure we prioritize the APM implementation with that transition that our fleet is going through. So again, 2023, just based on dispatch of units and then also some power purchase agreements that we have, we reached that 50% carbon-free for electric generation that year and exceeded it in 2024, but I haven't seen the numbers published yet. We do have a ton of growth expected, again, as a lot of utilities are talking about through data centers, EVs, and whatnot. So as much of this new generation as we can, we are building, owning, and operating rather than utilizing power purchase agreements. So a key part of our APM program is taking these workflows and tools that we've built to support one of our current priorities, which is our gas facilities, our combined cycle and simple cycle gas power plants, picking out tools that we can transfer over and implement for our new renewable generation and our new gas generation that's also expected in the next 5 years. I think at least 10,000 megawatts being built across our three regions. And even this year, we're taking a full-blown APM implementation on our largest hydro unit, so that'll be a new venture for us, trying to do from the very beginning through the end, including operator rounds, asset health, criticality before health and strategies, kind of the full range. And then kind of picking out key pieces that we can apply to solar and wind in the future. So a busy slide. I won't talk through everything that's on there. It has been cleaned up a lot, actually. But just wanted to remind folks that we've been at this for several years. I've been on the team for 5 years and stepped into leadership 2.5 years ago. So some of this was prior to my involvement, but the major starting point that I picked there would be our 4.6 go live. We are still on 4.6 and we're on-prem. You'll notice if you look farther to the right there, we're in the middle of a cloud migration. We're going to 5.2.2 and going to the cloud, and right now scheduled for user acceptance testing next week and go live in May, so excited about that. Yeah, we're excited. And then a couple of the key modules that we've been building out. I don't think the text is important to read, but building out operator rounds, and then our asset strategy, workflow, and then PM development in the recent years. And then at the bottom, just a reminder, our team has also been heavily involved in identifying gaps in condition monitoring, kind of tying that into our asset strategy work. And then we're executing a lot of instrumentation expansion for, again, mostly our natural gas sites and hydro this year. A large part of that is wireless vibration and doing some dissolved gas analysis for transformers, some advanced valve diagnostic testing, and experimenting with other technologies too. A brief run through of our operational risk workflow. Again, something I think that's been shared prior, but wanted to give a refresher or show this to audience members that aren't familiar. But essentially this has been in place now for several years. We can think of most of this as automated, right? We've done a lot of data integration. We have an M&D center that uses Smart Signal that's well established, so that's a big input to our asset health score. We have some data coming in from users, operator rounds, engineering rounds, testing, and then also have PI points linked to assets with set limits based on ISO standards or our own standards. And then, all those together combine to give us our asset health index, 0 to 100, help us get a picture real time of all our assets and the health. And then we bring in our asset criticality, and that combination there gives us a picture of risk that we can use to prioritize work through daily plant meetings or monthly reliability meetings, or looking farther out to budget planning, overall planning for years ahead. Am I cutting in and out? Okay. People in the back hear me okay? Half and half? All right. And then a couple key areas I want to just circle here that I'm going to talk about that we saw as problems with the workflow, and I don't mean problems with the design necessarily, but just how it maps to the data we have in our work processes in our plants. Those are two areas that I'll talk about and what we've been working on. The first is work order data, and that turns into kind of a big problem with a big solution. And then the other is a tool, this manual risk tool, which is another big gap we had, but was a lot easier fix, a lot easier solution for us. So I'll talk a bit about both of those. Jumping back to what feeds that work order data coming from SAP, I wanted just to outline that so it's clear. We have two categories, our PM data, right, our preventative maintenance plans, and overdue work orders, PM work orders impact our health, and also the compliance for the last 365 days, a rolling compliance number, and then also a corrective work order category where we are looking at open corrective work orders or breakdown work orders indicating, an asset's not performing well, not doing its job, not operating, and also excessive corrective work in the last 90 days. All of those combine into this one piece of that asset health index. So again, even if we had, say, overdue PMs, we had poor compliance, we had open corrective work, and we had a lot of corrective work in the last quarter, that would feed into one of those buckets in our overall asset health index and would bring that health index score down from only, say, 100 to 65, depending on how many data sources we have linked to that asset. Yeah, so tackling this, the reason we saw this as a problem, stepping back, is this dashboard we have to look at operational risk. We can quickly get a look at what the high-risk items are, and then our engineers or our ops managers can click in and look at what's driving that health score to be reduced. And what we found is our existing PM structure was inadequate. We had both PMs that were redundant, excessive, or seemed irrelevant to plant personnel and weren't getting executed, or at least weren't getting completed and closed out. So we'd have a lot of overdue work orders for PMs. I don't think we're the only one that might struggle with that, but definitely a challenge. And when we have that feeding our risk dashboard and we're giving our engineers, here's a list of risk items you need to look at, we really can't ask them to be clicking through and looking for irrelevant data. Any given day they walk into the plant, they have probably dozens of things they know are a problem and they could go and fix, and they don't want to spend time looking through false risk data from PMs that are overdue and seem excessive and not executed. So it was a strategic decision to ask the ESA team, Equipment and System Analytics team, to lead this effort, but we thought it was crucial for us to drive this change within the organization because we knew to drive adoption on that dashboard, we had to get better data in. And we also knew there were a lot of places where probably more so than excessive PMs, we had gaps in time-based work that should be executed but may not be. That's due just from years of running very lean and individuals at plants, determining what was critical and what wasn't, and making cuts, or maybe from our, conversion to Maximo or from Maximo to SAP, we knew we had gaps, and we really thought there was value to setting aside the time, revisiting our PMs and making improvements. So here's again our starting point. I won't read through all that, but obviously if we have that poor quality work order data, our PM data feeding into equipment health and cascading down to risk, we struggle to utilize that for budgeting and planning. So taking a step back at what should feed that was our asset strategies. We started with asset strategies. I think you could, or you may need to step one level farther back or farther up and do failure mode analysis to determine failure modes for assets, and then use that to drive the strategy. We were lucky we had access to a library of asset strategy templates. They're based on EPRI, and are a good starting point, although not necessarily something we could just take and click implement and run with. We definitely took those templates, reviewed them internally, reviewed with other fleet experts within our company. We reviewed what we had implemented for condition monitoring, and everything we could, we pushed to some type of monitoring rather than time-based work. We, like everyone else, are trying to move down that road of condition-based maintenance rather than time-based. So, if we had, a critical motor, we would, rather than, keep that minor overhaul and major overhaul in there as time-based work, we'd count on our vibration monitoring, motor testing, direct health indicators from temperatures and vibration to monitor that machine. And then when we start to see indication of health, we'll plan work. And we also knew, since this was such a big endeavor, we would have to make sure we take a targeted approach, like the slide I showed on our generation types. We chose to focus on just our critical transitional units, the natural gas, combined cycle, simple cycle units. So that limited it to roughly 8 sites. I had a slide with a bunch of different numbers of the critical assets, and I'm glad I didn't put it in here because they were much smaller than the last presentation, so that would have been a little upstaged there. But we roughly, our scope was those 8 plants. Each plant had 15,000 assets, and from that, our asset criticality analysis was pretty crucial in us narrowing that scope even more, so we could pick the 2,000 to 3,000 assets ranked as critical and work on strategies for those and make sure we drive accurate PMs on those assets and clean up PMs that exist that may not be on critical assets, but really focusing on the critical assets. And so we did use this grouping approach rather than taking a template from EPRI for this, say, motor and looking at one motor at a time, which we started out doing that, and it just took too long at our pilot plant. So we switched to a master strategy template approach. We would take, say, a grouping of similar asset types, so maybe motors, TEFC motors between 50 and 3,000 horsepower, and we'd say, again, as long as we have some of these monitoring technologies in place, or it's a small enough motor, we don't need to do electrical testing, we will apply this one strategy, and essentially it's just ensuring we have that time-based work for electrical testing and lubrication of some sort, whether it would be lube oil sampling or getting it on a grease lube route. So through that approach, we've been able to move faster and then plan to finish through 6 sites this year and knock out one more in 2026, that would be, and then I'm sure by then we'll have new generation we need to start working on. But the process is getting smoother as we go. And then from there on down, right, once we have better asset strategies, better PMs built in SAP, the value trickles on down to give us a better picture of risk in our operational risk workflow. So a couple examples of wins from the first plant we implemented this at was a 2-on-1 combined cycle site, and so we found that some of the most critical motors on site there for our large circulating water vertical pumps. We found that there was a PM that existed to, say, lubricate that motor, but we didn't have the details. We had just a list of assets in a description, so we couldn't track if they had completed lubrication on all 6 motors that are mentioned in there or just 1 or 2. We also found that this particular motor, even though it is the most critical and it had been attached to a pump that was a bad actor, even through all that, we didn't have flagged that there's 2 different oil types, upper and lower bearing. So that's the kind of thing we're finding as we go through and review this critical equipment for accurate PMs. I've also found things like our plant engineers used to use spreadsheets to track our safety valve testing to meet regulatory requirements, and we're trying to move them towards, we can use our SAP system, we can use APM to track that and not use spreadsheets, and sure enough, we have found a handful of valves that should be on that testing program that aren't. So we're starting to see that value through our asset strategy work. So that, again, an immense amount of work for our team to do the reviews, and then also I have people on my team building those plans in SAP. The other gap we had that I mentioned was this manual risk entry, and it's one, maybe it's common knowledge or seems obvious to everyone, but through kind of this automated workflow of all these different places we're getting health data, we know there's still things out in the plant that are a risk to our reliable operation, or financial risk or safety risk potentially. And so we've had this tool built now for a few years, and essentially it's just a simple method to enter a risk that's tied to an asset with a brief description, an option to assign a criticality if for some reason it doesn't have a criticality, and then to manually assign a health value based on best engineering judgment. And so we had this tool, and then in 2024 we actually had a few events that caused, well, the top event for us, unplanned downtime in 2024, was a pipe leaking that as we dug into it, we found had been identified as potential future problem in a 2015 report, and through turnover, through 10 years of fighting fires, that report, that PDF, the email, wherever that was saved, was lost, and so we couldn't do more frequent inspections or plan a repair, and ended up coming down to Band-Aid that and then plan a more permanent repair later on. And that was one of the drivers. Another example, a little bit different, not necessarily reliability impact, but we went into a CT major outage, and when we opened up our compressor, we found really significant hook fit wear on one of the compressor stages. And it's not an uncommon failure mode, but the wear was much more severe than we expected, and we had to essentially extend outage. And I think it was a 7-figure impact to the outage there. So that, again, is something that catches the organization off guard. We may need to pull some other projects that are planned in order to fix that. And again, we found that a previous outage, a decision was made. It looks like there's some wear in this hook fit, but we can make it to the next outage and we can fix it then. We just didn't have the plan, the resources on site ready to tackle that when we opened the compressor 6 years later. So yeah, you can see just a simple query we have. We're building equipment groups to help different teams visualize the risks that they've entered manually. And we have a lot of that tracked in our manual risk tool. So those failures are really key to starting the discussion, but really we got with our fleet directors and engineers, our operations directors, reliability engineering groups, and said, we have to find somewhere to document these manual risks. We have an option in APM, and so decision was made, we'll use APM as the database for us to track risks that aren't already captured through one of these automated workflows. And in the last 2 quarters, we've loaded over 500 risks. Some of the risks on that last slide are examples. There's really countless great examples that I looked through kind of in preparation for this. So that is exciting. I think this was a counterbalance to maybe the more resource-intensive strategy work. This is something that users, when we kind of communicate, we need somewhere to track these risks. Look at all these incidents we've had where we just needed to keep track of our risk. It's something people can understand and we can see the value in right away. So I think it's been good to kind of pair those two together so that we don't wear out my team or the people we're leaning on for strategy input through that strategy effort. And then, again, as promised, we have developed a baseline functionality to take these risks and basically prevent our engineers from needing to enter something in APM and then also go to our budgeting tool and enter something, say, for a 2028 outage. They don't want to have to enter something in both spots, so we're building queries in a process that hopefully will be more automated over time to to bring these risks, which I should mention are often linked to corrective actions in the form of recommendations, to take those recommendations where they exist and slot them out, enter a line item for budgets out in future years. And the big question is, why develop this risk tool and not just use an SAP work order or something else? But what we find is oftentimes we can have a project entered for this 2028 outage, and through budget reviews, it'll get pushed, it'll get canceled, and we have still a risk existing there, and it may not get tracked if we don't have a database in place there to keep it in front of people and ensure the work gets planned or scheduled for a different year.